PandoraFMS is a flexible and general-purpose monitoring software that can be used to monitor both operating systems and all kinds of network devices. Its implementation is extremely flexible and allows monitoring from tens of devices to hundreds of thousands of them in a single instance. Its architecture is composed of different services, a web console that is multi-user interface where the entire platform is managed without executing console commands. We use the free application server Apache and PHP, a database built in MySQL, Pandora servers that run different monitoring processes and can be deployed in a distributed way. Optionally, we can use a historical database to store all the information that we don't want to keep in the main database. For large environments, we recommend installation on Linux systems, but certain components can run from Windows systems. If you want to monitor more than 5,000 devices, we recommend a multi-mode architecture with a single management console that we call Meta Console. With the Meta Console, we're able to centralize the information of the different nodes in a single console, thus being able to console data or execute actions from a single point. For those environments with network structures beyond the reach of our main network, we can have a satellite server that will act as a communication bridge between our infrastructure. PandoraFMS allows integration with different software such as Tomcat, Hyper-V, Oracle, or JBoss. Additionally, you will have access to a library of plugins where you can find different developments to allow integration with other software. PandoraFMS home screen allows us to see by default a summary of the state of our servers, as well as our agents and modules. This view is completely configurable for each of the users that operate with our terminal. PandoraFMS performs the monitoring through the agents. We understand agent as each of the devices you want to monitor. This monitoring can be done in two ways, with software agent or with remote agents. Software agents are small programs that are installed in the devices we want to monitor and that allow us to collect all the information available and that we can obtain through native commands of the machine. However, remote agents are the ones we will use to monitor network devices or those devices where we are not allowed to install a software agent. Checks performed by remote agents are performed using protocols ICMP, TCP, SNMP, WMI, or through planning. Monitoring through SNMP is done by Pandora's own server, as if it were a normal agent. Pandora communicates with the device and asks for the information it may have. Monitoring using SNMP traps is synchronous and depends on the traps available in the machine. In case of an erroneous value, the device will be the one that sends the information to Pandora out of the agent's interval. This is an example of Agents View, where we can find general information about it. In the lower part of the list of agents, we find the modules. We understand as modules each one of the metrics that we want to collect in an agent. In this list of modules, we will find the name, the description, its state, as well as data and graphics. The information that we can see of the modules, we will find parameters such as the name, the description, the state, the data returned, or graphs with historical values. The modules have different states depending on the parameters we want to monitor. We can define different thresholds for the data we collect, and this will be represented according to a color scheme like the one below. In green, it will indicate that the module is working correctly. In yellow, it will indicate that the module is in warning state. The red color will reflect a critical state of the module, and the blue color when the module is not running. It hasn't received any data yet. When the module goes into an unknown state, this means that it has been receiving data and have stopped doing so. In the current view, we are looking at the example of remote agent. In this case, a switch is being monitored and we can see the available traffic in its different entrances and exits. Pandora Enterprise version allows us to work with agents remotely. This will allow us to save a lot of time and work in the configuration of these agents. We will have the agent's configuration file in Pandora's central console, and we will be able to work from here whenever we need it, adding modules or changing any configuration. We understand by alert the PandoraFMS reaction to an inadequate value of a modeled event or trap. For each of the alerts, we can define completely custom actions, such as sending an email to the system administrator, trying to restore the fallen agent, or open a ticket from our integrated ticketing tool Integria IMS. It also has a powerful events console. By events, we mean any change produced in the PandoraFMS system, be it the user login, a fallen agent, or the recovery of an alert. All these changes will be reflected in the events console. Each of these events is fully operable and will allow us to have great information as well as adding comments to the different operators of the system, or executing answers depending on the event we are working with. Another very practical feature that helps us identify and solve problems more quickly is event correlation. The correlation of events works in such a way that if an agent is generating many events in a short period of time, PandoraFMS will warn us that it is having an anomalous operation, and it will be easier for us to identify it and solve it. The NetFlow Viewer is a powerful visual tool that will allow us to control our network traffic and see which IP is consuming the most bandwidth at any given time. We will see the information reflected in real time, and we will be able to use it as a forensic tool to check when there are peaks in the traffic of our network. The log viewer will allow us to collect in the same console all the logs that are available for monitoring. We will be able to filter the results and perform searches according to the needs of our monitoring. PandoraFMS collects the logs through Elasticsearch and Logstash. PandoraFMS also has a powerful inventory tool that, thanks to the data collected through the software agents, will allow us to have control of both the hardware and the software that we have in our environment. We will be able to see the model of each one of the components of hardware that we have installed, and it will take an exhaustive control of the versions of the programs that exist in our devices. Policies are one of the most powerful tools that PandoraFMS offers. They act as templates to apply configurations to a great volume of devices at the same time. We will be able to define different configurations of modules, plugins, or event alerts to apply them to the agents in which it is necessary to apply the monitoring. Thanks to the power of the policies, we will be able to select as many agents as we want and have the configuration applied in less than a minute. This will allow us to save a great volume of time and effort, thanks to the powerful tool discovery of PandoraFMS. We will be able to make a scan of our network, and also we will be able to see represented a logical and topological map of our work environment. Our discovery system will allow you to remotely monitor environments in the cloud, such as AWS. You can also detect and deploy monitoring of all types of elements in the cloud without installing agents. This network scan will also allow us to apply custom basic monitoring templates for all our devices. The network maps will allow us to have great information, such as the relationship between parents and children of the different devices or the interfaces of the switches through which the other devices are connected. The network maps will also allow us to see represented all our virtual machines and to know their state. PandoraFMS has a tool to create transactional maps. We understand transaction as a set of steps or phases that make up a more complex task. It is executed and divided into phases. For example, the management of an issue. You can determine commands or scripts that will execute the actions as the phases pass. Each phase corresponds to the departure of a Boolean script. So when one of them is returned, another phase or phases are unlocked. Thanks to PandoraFMS, we will be able to monitor the user experience in both web and desktop. The user experience is based on automating web browsing sessions. By means of Pandora's tool, we will be able to make a recording in which a screenshot is taken for each click with the mouse, and these are registered or stored as steps, also saving the time taken by each one of them. Each of these steps will be reflected in a model that will be created in the web user experience agent. In case an error occurs, Pandora will make a screenshot showing us the state of the web at the moment in which the error occurred. Maps of service. A service is a group of resources that form a whole. In other words, we can see a map representing the elements that are part of the operation of a specific application or service, where a criticality is assigned to each of the elements that compose it to see how it affects the viability of the service itself. Each of the elements, individually and through its state, determines in a configurable way the global state of the service provided. For example, here we find represented a map of PandoraFMS service as components, and we find the total service that would be Pandora. And underneath the elements that are necessary for Pandora to work, the Pandora's code, which would be the database, Pandora service, and console status. With these three sub-services, we will be able to create a map of services. In these sub-services, we find the modules or elements that we consider essential for the service to work properly. In this case, the operation of the service and the MySQL connection through its port. If we go to the server section, we see the three sub-elements that are the server state, that is, if the binary is running or not, the tentacle state, which is used to send and receive information between the Pandora agents, and the data in which the directory is located where the XML are stored. We also assign weights, and in this case, for example, we can find that the data in directory does not work correctly, but it does not represent a vital problem for the general execution of Pandora's service, so that a specific element could be in critical condition, but it wouldn't spread upward. In the following item, we can see in detail the weight and values assigned to each element and better understand which are the thresholds necessary for each upper element to become critical or warning based on its lower elements. In this way, we would have configured our map of services. The visual consoles. In this way, in a screen, we can group different graphics or representations of the data collected by Pandora. Visual consoles are screens that are completely personalized by the user and that are placed on monitors in the office so that they pass one after the other and the monitoring is seen. In this example, we're drawing a world map through the typical colored light bulbs, representing the different places that are being monitored, and we can even navigate through them. If, for example, we click on the Spain icon, we will access another additional visual console in which we see the branches only located here. And if we go further and click in Madrid, we will enter its visual console, which opens its components such as its server, the database, mail, and web page. The useful thing about this is that everything underneath is inherited. That is to say, if, for example, in Madrid, the email services were not working, this one would pass to the red one, changing the color so much in the ball of Madrid as in the one of Spain. This way we can quickly see whether we have an alert, a notification, or something we need to review. PandoraFMS offers us the possibility to visualize the monitored data in an orderly way in a report. We can generate these reports in different formats such as HTML, JSON, CSV, or PDF, or even be sent by mail automatically. You can find data represented in different ways: simple graph, predictive graph, top N, SLA projection graph, personalized graph, etc. Let's go to a SLA report, which are usually the most common ones. We can find the information divided in up to 4 spaces of time. One shows us the data in a general way. Another one collects information during a monthly period, the availability of data collected during the week, and another that so exhaustively for each hour of the day. If we analyze the details that are shown in each section, we see that in the general area, it shows the agent, the module that receives the data, if we have established minimum and maximum values, the limits percentage of SLA, the compliance percentage, and the state. In the following points of the report, we see sections that show the total number of checks made, the fails and the correct ones, the total time in the case of the weekly ones that are broken down in the time that have worked correctly, when there have been errors, how long it has been unknown or started. With the dashboard, Pandora allows the creation of individual monitoring pages for each user, in which you can add more than one window, in which to include different monitoring maps, status summaries, or graphs. With these, we manage to show all the information that a user may need in a single view and avoid having to navigate through the different menus. Each dashboard can have several different widgets added to it, each one occupying the cell. Each widget has its own features and configurations. Within a dashboard, we can include more than 20 different widgets that allow to show data as a list of events or as a module graphs. To add more cells, just go to the options item and set the number we're going to use. Also, here we will have to assign a name to our dashboard and to indicate if it will be a private type or visible for a group. In short, the power and flexibility of PandoraFMS allows us to unify the network monitoring with systems and applications with practically unlimited scalability. Thanks to our Meta console and the satellite servers that make possible the task of generating thousands of networks queries per second in a distributed way.